Welcome to a new module focused on a powerful Python feature introduced in version 3.10, the match case statement. This is Python's answer to the switch or case statements found in other languages, providing a clean, structural way to handle multiple comparison conditions. 1. What is structural pattern matching? The match case statement isn't just a simple replacement for if-elif. It introduces structural pattern matching, which means it can compare an expression not just by its value, but also by its structure, allowing us to easily deconstruct data types like lists or objects. 2. Basic syntax and anatomy. The basic syntax starts with the match keyword, followed by the expression you want to test. Below it, you define one or more case blocks. Each case is a pattern. If the expression matches the pattern, the corresponding code block is executed. 3. The wildcard case. Notice the last case followed by an underscore. The underscore or wildcard pattern is similar to the else block in an if-elif-else chain. It acts as a catch-all, matching any value if all preceding cases fail. It should always be placed at the very end of your match block. 4. Variable capture. A powerful aspect is variable capture. If you use a single variable name in a case, not a literal value like start or 200, that variable name will match any value, and it will bind that value to the variable. This allows you to process the value within the case block. 'To summarize, this feature simplifies complex branching logic significantly. Our next lecture 32.02, Match Case versus If-Else. See you there. Welcome back. In the last lecture, we introduced the basic syntax of the match case statement. Today, we put it into context by directly comparing it with the long-standing Python method for multi-way branching, the if-elif-else structure. We will see how match case can simplify your code. 1. The traditional if/elif/else approach. For many years, this was the only way to handle multiple discrete comparisons in Python. As you can see, the structure requires repeated checks of the status variable, which can lead to verbose code and decreased readability when the logic becomes long. 2. The match case equivalent. Notice how much cleaner the logic is here. The expression to be checked, which is the status variable, is stated once at the top with match status. The code then clearly lists the possible cases. This clearly isolates the different logical paths, making the intent immediately obvious and the code easier to maintain. 3. Key takeaways. While if-elif-else can handle any condition, match case is specifically designed for structural pattern matching. It offers better readability for simple value-to-action mapping. In this basic example, match case is slightly cleaner and often more performant because it optimizes the branching process behind the scenes. However, remember that for complex conditional logic involving range checks or Boolean operations, if-elif-else might still be the appropriate tool. To summarize, use match case for clarity when mapping single inputs to specific outputs. Our next lecture 32.03, Syntax. See you there. Welcome back. While the basic match case syntax is straightforward, its power truly shines in more advanced use cases. In this lecture, we dive into two crucial syntactical features: matching multiple literal values in a single case and adding conditional guards using the if keyword. 1. Combining multiple literal values, or operator. Often, several distinct values should trigger the same action. Instead of writing multiple identical case blocks, you can use the vertical bar or operator to combine them. This pattern is concise and greatly improves readability, as shown here for grouping HTTP status codes by category. 2. Conditional guards, if keyword. When simple value matching is not enough, you can add a conditional guard using the if keyword immediately after a pattern. The guard expression must evaluate to true for the case block to execute. This is how you implement range checks, greater than or less than conditions within the match case structure. Notice we use a variable x to capture the value and check the condition against it. 3. Combining or and if guards. You can combine both features for complex yet readable logic. Here, the case matches if the status is either logged in or premium user, but only if the additional condition, that the user session active boolean is true, is met. This demonstrates the expressiveness of the full match case syntax. To summarize, these features significantly extend the reach of match case beyond simple equality checks. Our next lecture 32.04, Using Collections. See you there. Welcome back. The true power of Python's match case is not just replacing simple if-elif statements, but its ability to perform structural pattern matching, especially when dealing with collections like lists and tuples. In this lecture, we will learn how to deconstruct or extract data directly from these structures. 1. Matching fixed-length tuples. The match case statement can match both the length and the content of a tuple. In this coordinate example, we check specific fixed values like 0 and use variable names like x and y to capture the corresponding values if the structure matches. This provides an elegant way to handle structured data. 2. Matching lists with wildcards. Match case works similarly with lists. Here, we match based on the length and the type of the elements inside. Case 2 matches any list of 3 elements where the first element is CMD, capturing the second and third elements into local variables for processing. This is a common pattern for processing command lists or data logs. 3. The splat operator asterisk for subsequences. For collections with variable length, we use the splat operator or asterisk similar to argument unpacking in Python functions. It captures all remaining elements into a list named details. This allows you to match the beginning and end of a sequence while collecting all the intermediate elements, making it ideal for parsing complex logs or headers. To summarize, structural pattern matching is a fundamental benefit of match case over traditional if-elif. Our next lecture 32.05, Using Constants. See you there. Welcome back for the final lecture on match case syntax. A frequent source of confusion is how the statement differentiates between a new variable that captures a value and a predefined constant that holds a specific value. We will clarify this distinction using Python's naming conventions and show you how to properly use constants in your patterns. 1. The ambiguity of variables in patterns. By default, any single lowercase name used as a case pattern is treated as a capture variable. This means it matches any input value and binds that value to the variable name. This behavior prevents subsequent cases from being reached, which is the source of the common name capture makes remaining patterns unreachable error. 2. The mandatory .access rule. To correctly match against a constant value, you must force Python to recognize it as a constant, not a capture variable. The safest and most common way is to define constants within a class or module and use the dot syntax to access them, like status.ok. This dot access signals to the match case engine that this is a constant value to be matched against, resolving the ambiguity and the syntax error. 3. Avoiding variable capture. As a final recap, always use the _wildcard case _ for your final, catch-all pattern, or whenever you want to match a value without capturing it into a named variable. Using any other lowercase name will create a capture variable, which is usually not what you intend for a catch-all case. To summarize, understanding this constant matching rule is essential for writing robust and bug-free match case statements. We now conclude our module on match case. Our next lecture is a brand new module, 33.01, using virtual environment. See you there.